In this lesson, we want to review graphing linear functions. So most of you already know how to graph a linear equation in two variables. This will pretty much be a review for the majority of you. But in case you've never seen this topic before, it's something that's very easy and you can just pick it up from the lesson today. So let's start out with just a basic definition of a linear equation in two variables. We basically have two variables involved. Typically we use x and y. So we have ax plus by equals c, where a, b, and c are going to be real numbers. And we can say that a and b, the coefficients for x and y, can't both be 0 at the same time. Now, when we work with a linear equation in two variables, as long as we don't have a vertical line, which we'll talk about later on in today's lesson, you have a function. So for each x, you're going to have one unique y, okay? So we can call them linear functions. We can say we're graphing linear functions or we're graphing linear equations in two variables. It's the same thing. And I could replace this f of x with just y, right? I could say y is equal to, in this case, a times x, and then plus b, okay? So if this guy is solved for y, we can replace y with f of x or g of x or h of x or whatever you want to use if you're writing this in function notation. All right, so how do we sketch the graph of a linear function? Well, right now we have f of x equals 2x minus 5, and essentially the quickest way to do this is to solve the equation for y, which in this case it actually is, right? I could replace this f of x with y equals 2x minus 5. So you solve it for y, and then you're going to have it in something known as slope-intercept form. You can plot the y-intercept, and you can get additional points using the slope of the line. Now, because it's not typically taught like that in the beginning, I'm going to go through kind of the earlier steps, kind of the more tedious methods that you use to do this. So let's start out by just making a table of values. And then towards the end of the lesson, I'll show you this kind of quicker technique. It's something that you pretty much use after you get out of this section because it's the fastest way to kind of accomplish this task. So when you first start out, you might be told to make a table of values. So in other words, I would choose a value for x and solve for y, or choose something for y and solve for x. The problem with using this method is you have to be able to kind of choose these smaller integers, something that's going to fit on the coordinate plane that you can draw yourself, right? So you want smaller integers. You want to make sure they're integers. You don't want to get fractions or decimals, things that are really hard to kind of put into a graph. So what I'm going to do is I've already kind of pre-chosen some points that are going to work well for us. And additionally, if it's solved for y, I can just plug things in for x and see what I'm going to get for y. So if I choose, let's say, values for x of -2, let's say 0 and 5, I'm just going to plug in for x and see what I get. So let's start out with an x value of -2. So I can notate this by saying f of -2, that's just the function's value when x is -2. This equals what? It's 2 times -2 and then minus 5. 2 times -2 is -4. -4 minus 5 is -9. So f of -2 is equal to -9. So basically we have an x value of -2 and an f of x value or a y value of -9. So x comma y would just say this is -2 comma -9. So this is going to be a point on the line. Then we have an x value of 0. So I want f of 0. So what's that going to give me? So let's plug in a 0 here. And what are we going to get? Well, 2 times 0 is just 0. So I can just kind of line that out and say, okay, we just have -5. So if x is 0, y is -5. So we can say 0 comma -5. That's my x comma y. And the last one I want to check is an x value of 5. So I want f of 5. So let's see what that gives me. So 2 times 5 is 10. 10 minus 5 is 5. So if x is 5, y is going to be 5 as well. Okay. So this gives us 3 ordered pairs that we can kind of plot on the coordinate plane. And then once we've plotted those, you draw a straight line through them and you put arrows at each end to indicate the line is going to continue forever in each direction. The main idea here, when you use this kind of table of values method, you only need 2 points to make a line, right? But a third one is usually something you want to do just to get a check, just to guard against any errors that you might make. All right, so I've kind of pre-drawn everything just to make it a little quicker. So again, we had -2 comma -9. And on my coordinate plane, if I go 2 units to the left, 9 units down, that's here. I had 0 comma -5, which is starting at the origin. I just dropped 5 units, so that's right there. And then I also had 5 comma 5. Okay, so at the origin, I go 5 units to the right and 5 units up. So that's right there. You can label your points if you want. So we can say this is 5 comma 5. We can say this is 0 comma -5. And over here, I'll label this one to the left. I'll say this is -2 comma -9. Okay. Now what you would do is you would make sure that those 3 points line up, right? The reason you do a third point as a check is, let's say you get a point somewhere over here. Well, you know that you wouldn't have a line that does that, right? That doesn't make any sense. So that third point is guarding against errors for you. And believe me, everybody makes errors when they're doing math, right? There's a lot of silly mistakes that just happen because you might not be paying attention or you might not be completely focused at the time. Lots of things can happen, so it's good to have 3 points, again, to guard against errors. So provided these things line up, which in this case they do, you just sketch a line through the points and you put arrows at each end and you're done, right? It's a very simple process. All right, so let's just trace over this. And I'm not a good drawer or a good tracer, but I do the best I can. So you can label this. We'll say this is f of x is equal to 2x minus 5. Okay, let me make that a little bit better. I'll just kind of label it over here. Again, f of x, or you could say y if you wanted to, equals 2x minus 5. Okay, so that's the graph of that line. Now, let's talk about intercepts, x-intercepts, y-intercepts. These are concepts that, again, you probably know from your elementary or intermediate algebra courses. Essentially, the intercepts are the kind of spots on the graph where you intersect the axis, right? It could be the x-axis, that's going to be the x-intercept, or the y-axis, that's going to be the y-intercept. So on the next page, I've kind of pre-drawn these in for you. So essentially what you'll see is that the x-intercept, again, if I look at the x-axis, where do I hit the x-axis? Well, I hit right here, okay, right there. So the coordinate is 2.5 comma 0, okay, and I'll talk more about this in a second. For the y-intercept, again, I'm thinking about the y-axis. So for this guy, where am I going to hit? Well, I'm going to impact right there, okay? Now, I want you to notice something, and this is very important, something you definitely need to know. When you look at the x-intercept, where is y in terms of its coordinate when you're on the x-axis? Well, it's always going to be a 0, right? If I think about my y values, if I'm on the x-axis, basically I'm here or I'm here or I'm here. My y value is always 0. So to find the x-intercept, all I need to do is plug in a 0 for y and solve for x. So in the equation we had was y, or you could say f of x, so y equals 2x minus 5. Plug in a 0 for y, and solve for x. So add 5 to both sides of the equation. You get that 5 is equal to 2x. Divide both sides by 2. And you find that 5 halves is equal to x. And again, that's just my x coordinate when y is 0, or where it's going to impact the x-axis. So that's my x-intercept. Again, that's right here. 2.5 is the same thing as 5 halves in decimal form. And then comma 0. Okay, so 2.5 comma 0 or 5 halves comma 0, that's the x-intercept. Now similarly, let me just erase this. If I want to find the y-intercept, think about what happens when you're on the y-axis. The x value, or the x coordinate, is always going to be 0, right? Because I'm here, or I'm here, or I'm here, or I'm here, right? I'm not moving at all from the origin horizontally. I'm just moving vertically, right? Somewhere on the y-axis is where I am. So what happens is I can solve my equation for y once I plug in a 0 for x. That'll give me my y-intercept. So let me erase this, and we'll say again we had y was equal to what? It was 2x minus 5. And what I would do is plug a 0 in there. 2 times 0 is 0. I'm just left with negative 5, right? So if x is 0, y is negative 5, so that's my y-intercept. Now, the good thing about kind of the equations we work with, it makes it quicker if you have it solved for y. If you have y equals 2x minus 5, you'll notice that this part right here gave me the y coordinate of the y-intercept. That is not a coincidence, okay? That's always going to be the case, because when it's solved for y, when y is by itself on one side, what happens is you have something times x and then plus some value here. In this case, it's plus negative 5. Well, plugging in something for x here of 0, okay, makes this go away, and I'm just left with this, right? So that gives me my y-intercept every time. Later on, we're going to talk about y equals mx plus b, which is the slope-intercept form of the line. This is the fastest way to graph a line because we'll immediately know the y-intercept, which is 1 point on the line, and we can generate additional points on that line using our slope. Okay, but we'll get to that later on. All right, let me show you something known as the intercept method. This is something you would see in your textbook. Typically in Algebra 1 or Algebra 2, as you get further along in algebra, in a college algebra, you get into something like pre-calculus, they won't spend a whole lot of time on this method because, again, it's much faster just to use the slope-intercept form of the line to sketch the graph. But the intercept method just basically relies on you finding the x and the y-intercept as points, a third one to guard against errors if you want to check. but you really only need 2 points to make a line. So in other words, I would plug in a 0 for x and I would plug in a 0 for y. So I would find the x and the y-intercept. That gives me 2 points. Again, if I don't want a third point as a check, I'm pretty much good to go, right? I can graph my line. So let's go ahead and do this real quick. We have y equals x minus 4. Again, I just replace f of x with y. And if I want to find out what is the function's value when x is 0, again, what I'm going to do here is just plug in a 0 for x. So it's just like if I had f of 0, and this equals what? 0 minus 4, which is negative 4. So if x is 0, y is negative 4, so we have 0 comma negative 4, okay? Let me erase that. And then what about if y is 0? So basically this guy right here is 0. Let me just erase this and I'll just kind of do this over here. Let's replace f of x with y to make it a little bit easier for you. So y equals x minus 4. Replace y, or again, f of x with 0. What do we get? We'll just add 4 to both sides of the equation. You're going to find that x is equal to 4, okay? So this guy's 4, so we would have 4 comma 0. So you can get a third point as a check. Again, I always recommend this because you might make some mistake. So let's go ahead and say that we want to find the value of y when x is just 2, okay? So f of 2 is what we're trying to find. So we'd have 2 minus 4, which equals negative 2. So we would basically have negative 2 here for y. So 2 comma negative 2 is our ordered pair. Just going to copy those. Let's go to the coordinate plane. All right, so again, I've pre-drawn this just to make it a little faster. So those are our 3 ordered pairs. So 0 comma negative 4, again, the x value is 0 here. So what does that tell me? That's my y-intercept, right? That's where we're going to cross the y-axis. So from the origin, just drop 4. That's right there. That's going to be 0 comma negative 4. And let me make that a little better. And again, notice how that's where we're crossing the y-axis, okay? That's the y-intercept. Then you have 4 comma 0. So that's going to be up here, right? Go 4 units to the right. You don't move it all vertically. So this is 4 comma 0. Let me make that better. And again, this is my x-intercept because y is 0, right? So this guy is where we cross the x-axis. All right, so the last point is just for a check. So we have 2 comma negative 2. So 2 units to the right, 2 units down. So that's right there. This is my 2 comma negative 2, okay? So I've already sketched the line that goes through these 3 points. Again, just make sure it lines up and it's straight. If you get a point somewhere over here and you have these other 2 points there, you know, it doesn't make sense. It's not going to be a line. So then you know you made an error. You've got to go back and kind of recalibrate some things. All right, so let's go ahead and just sketch the line. Okay, and again, you want to put arrows at each end. And then a lot of times people like to label their line. So let me just kind of draw an arrow here and say this is the graph of f of x is equal to, again, this was x minus 4. All right, so as I alluded to, using a table of values is fine when you get started, but it's very slow and it's very inefficient. You got to go through and generate all these points. It's kind of a waste of time, to be honest with you. Once you learn kind of how to put an equation in slope-intercept form, it's the preferred way to graph a line, okay? So basically, slope-intercept form is like this. We have y is equal to m, the slope, times x plus b, the y-intercept. So this guy's the slope, and the y-intercept will occur at 0 comma b, okay? Again, if I plug in a 0 for x, that's how I find my y-intercept. This is gone. I'm just left with y equals b, okay? So that's why that works. Now, the reason we have m as slope, we'll talk about over the next 2 lessons. We're going to talk about slope in general in the next lesson. And the lesson after that, we're going to talk about equations of lines. So we'll talk about the standard form of the line. We'll talk about slope-intercept form. We'll talk about point slope form. I'll show you where all this stuff comes from. But for right now, we just need to know the basics. And that is that the coefficient of x is the slope. And this b right here is our y-intercept. All right, so what is the slope of a line? Well, again, we're going to go way more into detail on this in the next lesson, but slope is basically the ratio of the vertical change, which we call the rise, to the horizontal change, which we call the run. So let's say we had f of x equals 3/5 x minus 2, or again, we can write y equals 3/5 x minus 2. It makes no difference if you use this function notation or you use y, okay? It doesn't matter. It's the same thing. So the coefficient of x is my slope, and my y-intercept, again, is this guy over here. So it's this guy over here. So y equals mx plus b. This guy is my m, 3/5. My b, my y coordinate for the y-intercept is negative 2. So all you need to do is plot the y-intercept first. So the y-intercept occurs at 0 comma negative 2. So let's plot that guy. So from the origin, I'm just going to drop down 2. So that's going to be right there. That's my 0 comma negative 2. And I'm going to use my slope to get additional points. So slope is rise. It's rise over run. Okay, so if this is 3/5, what this means is that my rise is telling me how much I move vertically to get to the next point. My run is telling me how much I move horizontally to get to the next point. So a rise of 3 tells me to move vertically 3 units. So go up 1, 2, 3. A run of 5 tells me to go to the right by 5. So 1, 2, 3, 4, 5. So that would be the next point on the line. So you would have 5, 1. Okay, so that's an ordered pair. And then you can do this backwards if you want. So I can also say this is -3 over -5 because negative over negative is positive. Now, I want you to think about this. When you think about rise or vertical movement, a positive means you're increasing, so you're going up, right? On the y-axis, we increase as we go up. A negative is going to mean we're going to go down, right? We decrease on the y-axis as we go down. So if I have a -3, a rise of -3 is going to tell me to decrease by 3 units or go down 3. So 1, 2, 3. Then a run of -5, again, with the x-axis, you go to the right, you're increasing. You go to the left, you're decreasing. So what I want to do now from here is go to the left 5 units because I have a -5. So I want to go 1, 2, 3, 4, 5. And so this would be a point on that line. So this would be -5, -5. So -5, -5. And you can check these points to make sure that they work. We know 0, -2 would work because if you plug in a 0 for x, you get -2 for y. But let's check these other ones. So 5, 1, does that work? Well, if I plugged in, let me kind of do this down here. If I had y equals 3/5 times, I plug in a 5 for x, would I get a 1 for y? Well, these cancel. 3 minus 2 is 1, so that one's good to go. Let's check the other one. So again, 3/5 times x minus 2. The other one was -5, -5. So if I plugged in a -5 here, what would happen? So this guy would cancel with this guy, but it would be negative, right? So I'd end up with a -3. So you'd have -3 minus 2, which would give you -5. So that one's good to go as well. So look how quickly we found kind of 3 ordered pairs. We're basically good to go now. And so we can draw a line connecting these points. Okay. Let me just put arrows at each end. So that would be my line, right? And again, I can label it if I want. I can say this is f of x is equal to 3/5 x minus 2. Okay. Look how much quicker that is versus generating a table of values. And a lot of times it's not solved for y. So it's kind of hard to figure out what's going to be an integer answer and what's not. With this, you have your y-intercept and you can plot additional points using the slope. Again, this kind of concept of rise over run. Okay, let's look at another one of these. So we have f of x equals -4/3 x plus 1. Again, if you don't like the f of x, you can say y equals -4/3 x plus 1. And again, when it's in this format, we know y equals mx plus b. M is the slope, it's the coefficient of x. So it's -4/3. B is the y coordinate for the y-intercept, so it's going to occur at 0, 1. Okay, so let's plot the y-intercept first. 0, 1 is going to be right there. And let me use a different color because that doesn't show up very well. So I can label that if you want. It's 0, 1. And then you get additional points using your slope. So m, the slope, is equal to -4/3. And again, this is my rise over my run. Okay, so my rise is -4. Again, if I'm talking about rising or moving vertically, if it's a negative, I'm going to go down. If it's a positive, I'm going to go up. So go down by 4 units. So 1, 2, 3, 4. My run is +3, so that means I'm going to the right by 3. 1, 2, 3. So that's a point. So this is 3, -3. So 3, -3, that's a point. And then you can do this again if you want. So you can go down 4, 1, 2, 3, 4. To the right, 1, 2, 3. So you can put a point there. That's going to be at 6, -7. And you can also reverse this. Remember, if I have a negative over a positive, it's the same as a positive over a negative. So I could start here and I could go up 4. I could rise 4, 1, 2, 3, 4. And I could go to the left 3, right? A run of -3 just tells me to go to the left 3. So 1, 2, 3. So that's a point there. It would be at -3, 5. Okay. And you can check all these points if you want. I've already checked them. I know they work. So it's up to you if you want to pause the video. Again, you'd plug in a -3 for x, verify you get 5 for y. Plug in a 0 for x, verify you get 1 for y. Plug in a 3 for x, verify you get -3 for y. And plug in a 6 for x, verify you get -7 for y. Okay, so now all we want to do is just draw our line through these points. Okay, and again, you want to put arrows at each end to indicate the line continues forever in each direction. And I'm just going to label it. I'll say this is f of x is equal to, we've got negative 4/3 x plus 1. All right, let's take a look at an example where it's not solved for y. In other words, we don't have y equals something, or we don't have f of x equals something, right? So in this particular case, as a linear function, it's not solved for the dependent variable y. So we're saying it's in implicit form, right? So if we want it in the format of y equals m the slope times x plus b the y-intercept, we just solve it for y, okay? It's pretty simple. So I would just what? Isolate this term with y involved first, so the negative 2y. Just subtract 3x away from each side of the equation to do that. This part would cancel. You'd have negative 2y is equal to negative 3x and then plus 6. To completely isolate y, it's being multiplied by negative 2. So let me divide both sides of the equation by negative 2. And let me slide this down so we have enough room to kind of complete this. So we know this is going to cancel. You have y is equal to, negative over negative is positive, so 3/2 times x. 6 over negative 2 is negative 3 or minus 3, okay? So our slope here, m, is 3/2. Our y-intercept will occur at 0, negative 3. So now this guy is solved for y, or it's in explicit form. So in this form, we can replace y with f of x or g of x or whatever we want, right? If we want to use function notation. So f of x equals 3/2 x minus 3. Okay, so let me erase everything, and let me just write my slope up here. M, the slope, is equal to 3/2. And again, this is the rise over the run. Okay, so just one additional step when you get this format. Not very difficult, still faster to solve for y, and just kind of use the slope and y-intercept to get your kind of line graphed. So the y-intercept is at 0, negative 3. So I would go down 3 units from the origin, so that's right there. And then my slope is 3/2. So again, the rise is 3, the run is 2. So I'm going to go up 3, 1, 2, 3, to the right 1, 2. So there's a point. Rise 3, 1, 2, 3, to the right 1, 2. So there's a point. So this guy is going to be 0, negative 3. Again, that's the y-intercept. That's on the y-axis. This guy is going to be 2, 0. So this is 2, 0. That's the x-intercept. It's on the x-axis. And this guy is going to be 4, 3. So 4, 3. All right, so let's sketch our line real quick. Right, let me just put an arrow at each end. And then we're basically done. If you want to label it, you can use the 3x minus 2y equals 6, or you can use the y equals 3/2 x minus 3, or you can use the f of x equals 3/2 x minus 3. It doesn't really matter. You're just labeling it and saying, hey, this equation or this function goes with this line. So I'll just say f of x is equal to 3/2 x and then minus 3, and we'll be done. All right, so now that we know how to work with most of the cases, the special cases that come up, you have horizontal and vertical lines. These are very easy to draw, okay? So a horizontal line occurs when y, or you could say f of x, is set equal to some constant. In your book, you'll probably see it called k, or it could be called something else. It doesn't matter. So basically, you have f of x is equal to some number. Let's just say it was 5, okay? Or you could see this as y equals 5. These are the same. I just replaced y with f of x. So basically what you can do here, to think about this as a linear equation in 2 variables, if you had y equals 5, you could say you have 0x plus y equals 5, okay? No matter what you choose for x, when you multiply it by 0, it goes away. So you're still just left with y equals 5. So what happens here is that no matter what value you choose for x, if you're thinking about ordered pairs, y will always equal 5, so I can choose 1,000,000 for x, y equals 5. I can choose 3 for x, y equals 5. I can choose negative 1,000,000,000,000 for x, y equals 5. So what happens is you end up with a horizontal line that basically crosses the y-axis at this value here. In this case, it's 5. It could be, whatever you have. If it was 7, it would cross the axis at y equals 7, so on and so forth. So to see an example of this, let's say we had f of x equals 3, okay? Or again, you could write y equals 3 if that makes you more comfortable. So all you need to do to graph this line is go up to 3 on the y-axis. So let's just say right there. And we draw a horizontal line that crosses through that point, 0, 3. Let me make that a little better. I'm just going to use my eraser and just kind of knock that part off. And I'll just put an arrow at this end and an arrow at this end. It continues indefinitely in each direction. So if you wanted to kind of prove this to yourself, again, you can write this as 0x plus y equals 3. And you could pick values for x and kind of generate some ordered pairs. So think about this. If I picked, let's say, negative 3. So negative 3 times 0 is 0, so that's gone. So y equals 3. So you go to negative 3, 3, so that's a point on the line. You could say if x was 0, y equals 3. So 0, 3 would be this. You could say if x equals 3, okay, plus 3, 0 times 3 is 0, you'd have y equals 3. So no matter what you choose for x, it's not going to matter because y is always going to be 3. So that's what creates this horizontal line, again, that impacts the y-axis at 3. All right, let's look at another example. So suppose we have f of x equals negative 4. Again, all I've got to do is go down to negative 4 on the y-axis. So that's going to be right there. This is my negative 4. And just draw a horizontal line that impacts that y-axis at negative 4. So let's do that real quick. Okay. So this would be f of x equals negative 4. All right, let's wrap up the lesson and talk about the last special case scenario. This would be when we encounter a vertical line. So this is going to occur when x is set equal to some constant value. In this case, we're not going to have a function. So this is the only case where you have a linear equation in two variables where you don't have a function. And you might say you don't have two variables, but again, you could write it as x plus 0, y equals a if you wanted to. So you have two variables involved. This is the only case where you're not going to have a function. This one single x value, in this case it's a, but it could be whatever, right? You replace that with 3 or 10 or a million or a trillion, whatever it is. Basically, that one single x value is going to be associated with or paired up with an infinite number of y values, okay? So it's definitely not a function. So let's say we had x equals negative 6. And again, you could write this as x plus 0, y equals negative 6 if it makes you feel more comfortable. So for anything that I plug in for y here, it just goes away, right? So I'm left with x equals negative 6. So essentially for this guy, you go to negative 6 on the x-axis now, and I can kind of just highlight that. Basically, I'm just going to draw a vertical line there. Okay. And I went a little bit over, so let me just kind of erase some of this. And I'll put my arrow at each end. So this is x equals negative 6. Again, just find out where this number here, whatever it's equal to, is on the x-axis, draw a vertical line, right? Because no matter what value I choose for y, x will always be negative 6. If I choose 9 for y, x is negative 6. If I choose 6 for y, x is negative 6. If I choose 0 for y, x is negative 6, right? If I choose negative 1 trillion for y, x is negative 6. All right, so for x equals 8, how would we graph this? Again, look at 8 on the x-axis. 8 is going to be here, right? It's one notch to the left of 9. So again, I'm just going to draw a vertical line. Okay, and that one's pretty good. So we'll put an arrow at each end, and this is my x equals 8. So again, for a vertical line, x equals some number, find the number, in this case it's 8, on the x-axis, draw a vertical line that crosses through that on the x-axis. That's all you need to do.